Good morning, and thank you for joining us for our webinar on designing commercial PV systems. Before we begin, if you're experiencing any technical difficulties, please notify me by typing your question in the question section of your control panel on the right side of your screen and clicking send. I'll continue to monitor those, but it looks like none are coming in. So we will have a Q&A session following the presentation. You're welcome to submit your question at any point during the webinar, and we'll do our best to answer as many as possible after the presentation. There will also be a brief survey that'll pop up in a new window immediately following the webinar. If you wouldn't mind taking just a minute to complete it, and we'll reward you with emailing you a copy of the presentation that you're going to watch. If there are no further questions, which it looks like we're all good to go, I'd like to introduce AEE's very own Senior Applications Engineer, Glenn Hall. Excited to see this presentation this morning, Glenn. So without further ado, I will pass it over to you.
Okay, thank you. So as stated, my name is Glenn. I've been working with AEE as a Senior Applications Engineer, mostly with grid-tied and commercial PV projects for the past several years. Today we're going to be looking at and discussing what we see are the latest developing trends in larger commercial PV systems. We've seen a lot of major developments in the past several years. The latest transition to the current NEC code, of course, is prevalent. We see tariff concerns with the last administration that made module supplies uncertain, led to uncertain costs and supply issues. And of course, the pandemic has affected all of us there as well. So chip shortages, inverter shortages, and module concerns. So anyway, this should be a pretty exciting year. We're halfway through it, but we also would like to share what we're seeing from our customer base and from what we're seeing and submitting. So as we discussed, this is what we're going to be going over. Trends that we've seen in 2021. We're seeing new module formats, 72 cell versus 60 cell panels. We're going to look at using both of those for commercial projects, which one's best for yours project, giving your timeline and deployment. We're going to look at sizing inverters for PV systems and trends that we're seeing there. Rapid shutdown is always a concern as states more and more transition to the latest NEC code requiring module level rapid shutdown. Inverters as well are advancing. We're going to look at offerings from SMA, from SolarEdge, and also from Enphase on these systems. We're going to look at racking systems, specifically ballasted racking systems from Aerocompact. And also we have a new development from SnapNrack for roof mounted systems, composition roof systems in their new Speed Seal product. Also, we'll take a brief look at commercial ground mount racking systems if we have time, ballasted racking systems, utilizing SnapNrack Series 200 ground racking systems, and also the PLP Power Peak ground mount system. As we said, we're seeing lots of trends in solar modules. I like to think that we were fairly complacent in module sizes, where a 60 cell module was a size and everyone was making the same size module, 72 cells, as different manufacturers all had standardized on pretty much a 6-inch square. As module companies are trying to basically offer higher wattage panels, we're seeing them split to mono. We've basically seen polycrystalline basically disappear in the US market space, then moving to split cell mono, and also panels using HJT technology to drastically increase the watt size on the current offerings. They're also looking at lower current losses at each junction. They're increasing the amount of bus bars and other minor tweaks to a module that we're seeing increase the output. We're also seeing wafer size gradually increase. We're going from up to the M6 wafers and now up to 6.5-inch squares. As I mentioned before, we were pretty much standardized on like a 6-inch square for that 40-inch by about 65.5-inch standard module that we were used to for many years. So that really makes module sizing kind of uncertain, but we're getting more watts per module, but it also increases the sizes of the module. So please watch for pairing with any MLPE devices. So We're seeing, some optimizers like a P370 SolarEdge optimizer might work for this 350 watt panel, but the amperage for a different branded panel might be too much for it, so you'd have to upgrade to the P401 or the P505. And also carefully pick with rapid shutdown devices as well, just to make sure that you're within the operating parameters of those. Also, please check your module sizes when you're pairing with racking. SnapNrack, for example, had to completely redesign their racking rails and go to larger standard rails because the module sizes went from 39.5 to 40, and now we're even seeing 41-inch wide modules, and that would not fit our standard rail, especially for the ground racking systems. Aerocompact as well, their windscreens and their ballasting trays just didn't fit some modules that were there, and they had to do a complete redesign there. So please carefully check there, use any sizing tools that are available online, and check with your manufacturer prior to ordering product. Okay, so 72 cell modules is kind of the standard format that most people consider using. They try to, a larger module will require less optimizers, less attachments, sometimes less racking, but please plan ahead, because modules become very scarce towards the end of the year. So if you have the opportunity to bid a project and that project is being installed in Q4, chances are the supply of 72 cell modules may already be locked down for big industrial larger projects. So we're also seeing that people are locking down these projects much earlier. They're pre-ordering modules based upon our shipments that are expected in. And long lead times, though, if you have a short lead time horizon, you might benefit from using our 60 cell modules that are stocked rather than 72 cell modules that are a little bit scarcer. The 60 cell modules are not often higher cost per watt than the 72 cell modules. And typically we're seeing that for the 72 cell modules, you're needing to order in pallet size or container size quantities. And that could really mess up your cost structure as well if you end up with more modules than what you need. Sometimes we also see power densities that companies use their better cells for their 60 cell modules, so you might actually get a higher power density using a 60 cell module. 72 cell modules also might be restricted in areas that might have heavy snows. For example, Aerocompact and some other racking might grip the module in such a way that the snow loads, you're not getting the maximum snow load there, and you might require mitigation factors like a third rail or the use of the alpine brackets. 60 cell modules, if the modules are visible from the ground, are often more aesthetic because most of the times they come with a black frame. That might be a customer requirement. And as we mentioned, there's transitions underway to using split cell panels, HJT, format panels, and panels using larger format wafers. So typically now with a 60 cell module, we're seeing monocrystalline panels, standard stuff in the 340 to 350 watt range. Later this year, we've kind of gotten hints that we might get 360, 370 watts. The various highest efficiency monocrystalline panels can exceed 380, 390 watts. And of course, you got some of your special panels, like some sun power panels that could approach 400 watts. These are some of the panels that are offered through AEESOLAR. This is kind of current offering here. We don't currently offer the LONGi 72, but I put that one in there just for reference. We might see the LONGi, the Q-Cell 465 towards the end of the year, beginning of next year. That supply is uncertain as well. Okay, so when we're sizing inverters, so if you are new to commercial business, a lot of times, 1.2, 1.25 DC-AC ratio, that was kind of recommended standard when modules were high priced. We're seeing that the inverters, as they are a fixed cost, not coming down as quickly as module prices are. We're seeing higher and higher DC-AC ratios being used. Inverters such as SMA and SolarEdge, some of those inverters could be sized as high as 150% DC-AC ratio. For example, a 50 kW inverter, an SMA Core 1, we could design that to use and have up to 75 kW of DC solar array going into that inverter. And the result of that is that inverter reaches peak output much earlier in the day. We allow the inverter to clip minimally during high irradiance, but we're saving a lot of money in the amount of inverters that need to be installed. Fewer inverters are needed for each site, lower cost to purchase these inverters, deliver and install them, less maintenance, service, and warranty costs. And as a result, we can get more kilowatt hours at a lower overall cost considering everything. You know, those inverters aren't going to clip in the morning, they're not going to clip in the afternoon, they're not going to clip in the months of lower irradiance. So it results in much lower cost per generated kilowatt hour over the lifetime of the system. Also, people just getting into commercial projects, there's a tendency to try to, on flat roofs and sometimes on ground mounts, to, you know, have those higher tilts, thinking you're going to get, you know, you have to tilt at latitude, have to get these things tilted up. With the panel prices being what they are, and you're going to see in some of my layout displays later on, that the higher tilts, you know, we have larger inner row spacing that has to be left, so you're losing a lot of roof for ground space by having a higher tilt angle. So lower tilt angles, we allow more and larger PV arrays and more net energy that we can actually produce. We actually do have an east-west racking solution that completely eliminates inner row shading. That could be useful for some high-density projects. Also, lower tilts, you're going to see coming up. They cost less, there's less racking, easier to install, and much less ballast weight will be placed on a given roof, which could be a consideration. Some do consider facing an array to the west if you have high time of use evening utility rates. So check PV watts or other solar production tools like the SolarEdge Site Designer that could help you determine production results with different arrays and different tilts. We all know about NEC code, hopefully now. More and more states are adopting that. This is just a reminder, the difference between NEC 2014, where you have a 10-foot boundary around the array. Oftentimes you could put an inverter inside that boundary and thus meet NEC code. So it's a 600 volt limit in that area. But the NEC 2017 code, and it didn't change for 2020, there's a maximum of 80 volts in that area. So the use of MLPE, rapid shutdown devices at each module, is typically required. SolarEdge is looking into getting an exception where you're single optimized that can handle 2 panels in series, but we haven't really heard that has progressed terribly too much. So your P950 optimizer compared to your P960, the 960 has 2 inputs. That meets rapid shutdown currently. The 950 with 2 modules in series, that typically goes over 80 volts still, so currently is not allowed. Here's a quick map. Note at the bottom is where you can get this. So you can also just Google NEC NEC code adoption map. This one will come up, so definitely check your states. Currently, most states are on the NEC 2017 code, and states are starting to transition even to 2020. We still have a few holdouts there, or states that require code per each municipality. The ones in light blue and yellow, please check locally. You might still be under NEC 2014, or you are under local jurisdiction for rapid shutdown. Here is some of the rapid shutdown devices that we see being used on our systems here. So we have the APS MLPE rapid shutdown device. This is qualified for SunSpec compatible inverters and has been extensively tested and approved for SMA inverters, both the residential inverters, the smaller inverters for single phase from 3 to 7.7 kW output, and their commercial inverters, the Core 1 series, currently 33, 50, and 62 kW output. The Fronius SIMO Advanced commercial inverters are also approved for use with the APS rapid shutdown, as long as they're the SIMO Advanced. Please make an exceptional note that the SIMO 15208 is for ground mounts only. It's not a SunSpec capable inverter. So with these SunSpec inverters, the signaling device, the heartbeat producer that the device listens for to make sure that it is operating and can work, is in the inverter. It listens for that heartbeat. If that heartbeat is present, then the rapid shutdown device allows the module to be connected and produce. Once that inverter goes offline from a common disconnect device, or if somebody turns off the inverter, or if the grid loses power, then the inverters kick offline. Therefore, there's no more heartbeat. Therefore, these devices don't hear that, and they immediately cease operations and cut the voltage down to just the voltage of each module. Some older devices and some devices can also utilize the IMO Fire Raptor. This is a more expensive solution. There's a separate emergency switch. It is AC powered to each of those devices. Some of these can accept 2 modules, but for the most part, these are single module devices as well due to the current voltages. SolarEdge is another way to meet rapid shutdown, very common way. So there's single input optimizers like the P370, the P505, and commercial optimizers like the P860 or P960 that have 2 inputs. There's a picture of those over there. Those all meet rapid shutdown. You'll see the P860 and the P960 use more on their commercial larger inverters. They're attempting to qualify the single input modules, as I discussed before, the optimizers for rapid shutdown. There is an exception there that they're trying to get passed. I'm not certain and haven't heard that it has progressed, but maybe in Q4 we'll hear more. For smaller projects, specifically 3-phase 208 or single-phase projects, you also could use N-phase microinverters, especially if the array is broken up or basically tends itself to a microinverter type of environment, or if there's like steady shade conditions there, N-phase could be an option there. Anyway, string inverters, the traditional ones, we see them now being limited to use on just carports and on ground mount arrays, because remember that rapid shutdown requirements are only required for roof mount solar arrays for the most situations here. Definitely don't try to put your inverters inside. If you have a nice ground mount, don't put your inverters inside the basement of the building and then get surprised when the jurisdiction having authority wants you to install rapid shutdown on the ground mount. Don't do that. As mentioned before, okay, some of the inverter offerings we're seeing, the SMA Core series, Core 1 series of inverters. These are SunSpec. These have been out for several years and proved to be very popular inverters. We stock all 3 of these varieties, the 33 kW, the 50 kW, and the 62 kW. These output 3-phase 277 480 volt Y. Very flexible inverters. There is an SMA string designer, very easy to use. You can check voltages and module pairings with that. What's very nice about these inverters is they're kind of all in one unit. So there's 6 individual MPPT circuits, and each circuit has 2 string inputs to each one. So you can have varying string lengths on each of those MPPT circuits. So you can get a total of 12 strings into each of these inverters. And no fusing is required, since NEC code doesn't require fusing on 2 or 1 DC strings coming into an MPPT circuit. One note here, the inputs, since this is an inverter used both in this format of inverters used both for Europe and for America, and Amphenol H4 is more common in Europe. They do have Amphenol H4 connectors. So on the inputs, they do give you the connectors. They give you 12 connectors, 24 connectors, sorry, 12 male and 12 female to plug into the inverter inside the inverter shipment. But you do need the proper assembly tool to make sure that you can assemble those connectors to plug into these inverters. So we offer the Renistag connector tools and the stripping tools and the for use there. And also, if you do lose the H4 connectors, we can supply replacements there. Also note that all of these inverters that we're talking about are SA compliant, so they meet grid interactivity requirements to meet CA Rule 21 and Hawaii Rule 14H, so they all can be installed. This inverter is very nice as it comes with its own mounting feet. There's a nice little video on SMA that you can look at for the unboxing. Slides out of the box, you put the feet on, 2 little handles, put it in place either on a concrete pad or right on the roof. You can see examples of those mounting feet there in the photos. Very, very nice, easy to set up inverter there. There's an integrated AC and DC disconnect, and if this inverter ever does need to be serviced, the top part just comes off, and the inverter unit can be reinstalled fairly easily if that ever becomes an issue. We mentioned high DC to AC ratios. 2 people can move this inverter around with the included handles and get it in its right spot. There's Wi-Fi built into the inverter. So the data logger is included as well. And then you can also link multiple inverters with the new SMA Data Manager M. So 5 or more inverters would need that Data Manager M to network them. And we've seen these deployed on the roof, carports, ground mounts. Nice inverter, works really well. So a newer inverter for SMA, and this would be for large ground mounts only, is their Peak 3 inverters. There's a 125 kW inverter for 3-phase 480 volt grids and 150 kW inverter for 3-phase 600 volt grids. You do need to source third-party combiners from Solar Boss or other places, combiners and disconnects. SMA currently is only offering the inverter unit itself. Those do need to be fused disconnects since this inverter has a single MPPT input. These are SA compliant, so you can install them in California, Hawaii. Again, high DC to AC ratios are possible. The same Data Manager M communication gateway would be used if you have multiple inverters. And we're seeing these for carports or ground mount applications. And typically the break-even point we're seeing is when your DC size of the array gets to be about 500 kW or bigger. Otherwise, just use the SMA Core 1 for those smaller projects. And please note that SMA, these inverters are kind of, I mean, they're not built to order, but they don't, they want to forecast on here. So to get the best pricing, we need specific site info. We need some preliminary info to get you guys the best pricing and request specific pricing for your specific project from SMA. So be prepared to answer a couple questions about where the project is, when they expect to be purchased, when they expect to need to be on site so that they can forecast them. If they can forecast them, then they can better meet your demands. SolarEdge. SolarEdge is revamping their commercial inverter line. So it used to be that they had a basically standard of 14 kW 3-phase 208 and a 33 kW 3-phase 480. They introduced a Synergy line, which basically had a master 14 kW inverter in the middle and 2 slave units on the side. And on the larger format inverters, you had a 33 in the middle and 2 secondary units sitting on the side. They're increasing the power of all these units. So the 14-208 moves up to a 17.2, the 33-480 moves up to a 40, and then building upon that, their Synergy inverter units, the 3-phase 208 goes from a 43.2 to a 50, and their 66, which was 233 switched together, moves up to an 80, and their 100 kW inverter, which was 333 switched together, moves up to a 120. Also, it's a little bit different format. So the second picture down shows their new Synergy inverter format. The device at the bottom is their new Synergy master. This will determine the grid output of the connected Synergy secondary units as shown above. This would be an example of either the 50 kW, which would be 3 inverter units, each operating about 17 kW, or 3 40 kW units for a 3-phase 480 volt. So that inverter master on the bottom basically tells the 3 on the top what to do and what voltage they're operating at. we're looking forward to using these, especially with their higher wattage. We're expecting the first shipment of these to get to AEE in Q4. We still have plenty of the slightly older units for use for current projects, so definitely let us know how we can help you. As mentioned before, we have the dual input optimizers. The P860, P960 is typically used for these. As mentioned before, also they're working on the P850 and the P950 to qualify for rapid shutdown. And there's a new optimizer out there for higher wattage modules, the P1100. Those are all series string optimizers. So you plug 2 modules in series, and then the positive on the one module goes into the optimizer, and the negative of the other one goes in. Currently, that's over 80 volts, but again, they're trying to get a exception to that 80 volt maximum limit applied, and we'll hear more about that probably Q4 as well. So optimizers enable rapid shutdown at the module level, and the inverters basically put them near the point of connection, and we get very long DC wire runs. Very easy to connect these, and typically with SolarEdge you see much smaller, fewer DC strings with higher wattages on each string. The optimizers are setting the voltage and keeping it at the operating voltage of the inverters. Note if needed, you could always install single optimizers on separate strings if needed, if your array is really broken up, or if there is a need to match with an optimizer. We don't see that a whole lot, but it is an option. The SolarEdge site design tool at the SolarEdge website, the string design tool, really should be used for just about every project to make sure that you're getting the right optimizer and pairing it with the modules that you're choosing. We did mention Enphase for some 3-phase 208 projects. So Enphase standardized on their microinverters. It used to be that you had special cable that you had to use for 3-phase 208. Now you are the inverters auto detect whether it's connecting to 240 volts line to line or 208 volts line to line, and it's a single trunk cable, and you just would stagger the 2-phase breakers in the box and try to balance the output of the array for 3-phase applications. There is a special envoy that is used for 3-phase 208 or 3-phase 240 projects. So just make sure that if this is a 3-phase project that you talk to us, and we make sure that you get the correct commercial envoy to be used for that. So you do get module level rapid shutdown. Oftentimes you can do pretty high DC to AC ratios here. These are also, as we mentioned, UL 1741 SA compliant for Hawaii, California, and they're smart grid ready for any other states that might adopt that. And especially better for smaller projects or projects that we've had a couple of projects where they're afraid of theft of the modules or vandalism. And the choice was either to put a commercial inverter inside and have to do some crazy stuff, or just go with microinverters for carports and gas stations. So Enphase worked pretty well for that application there. Okay, so moving on to commercial rooftop racking, flat roof arrays. We're seeing many customers. I'm doing many designs each week for ballasted racking solutions. So ballasted racking is pretty quick and easy to design and install. You can look at some sample installation videos if you Google Aerocompact on YouTube, showing how quick and easy it is to set these up and out. Much fewer materials needed than rails-based systems. Typically, whole projects can be shipped out on a pallet or two. No long rails. You don't have a lot of roof penetrations and mounts. Avoids resealing the roof. Easier servicing the roof. If the roof ever does have an issue, you can just remove that part of the array, over service that one portion of the roof, and not have to take off the entire array there. We see much less roof warranty issues. There is some limitations though of using ballasted arrays. Seismic related building codes might mandate some penetrations, Typically, it's not suitable for roofs greater than 5 degrees slope. If you do have one, let us know. We'll see if we can do that with some penetrations. Roofs over 50 foot high tend to also break down a little bit. The ballasting starts to become really predominant and take over as you get higher and higher. The wind exposure is much more. The wind exposure definitely drives the ballast and the module tilt limitations, and be sure that your designer and or supplier uses the correct wind loads, exposure categories, and risk factors. We do see a lot of people going to competitive system sites, do their own calculations, not put in the right wind speed or building height or exposure, come up with a solution, and then come to us and say, hey, well, we want a competitive quote, and we come back and say, here you go. And they're like, well, why do you use all this material? Why is the ballasting so high here? Why is this more expensive? Well, that's because we're designing to the right wind speed and exposure, and we want the panels to stay on the roof. I've taken a couple calls in the past couple years where a competitive design system had a failure because it wasn't held down enough by ballast or penetrations, and then when you dig into it, either the wrong wind speed or the wrong exposure category was used. So we do double check all of our results. We do have the Aerocompact engineers look at them and certify them and make sure that they're designed properly. So be forewarned there about just doing your own solutions with an online tool with ballasting array and just ordering product without making sure that it's certified. So some comparisons back and forth between penetrating racking and ballasting racking. Roof penetrations, of course, into the roof structure. You anchor the array with penetrating racking. You have to seal those for the entire array life. We can get higher tilt angles. Ballasted racking is typically limited to 15 degrees or less. If you do have a project in the north of the country, or if you have, for example, an off-grid system where you do want to make sure you're winter tilting, we definitely want to go with a penetrating racking system. Pitched roof surfaces, there are some penetrating racking systems that can pitch up on a flat roof surface. Typically, we get much lower array weight with penetrating racking. So if the roof is limited in the amount of dead load it can handle, your penetrating racking would be a choice there. Roof maintenance, though, requires removal of the racking and then reinstallation of the penetrations. And sometimes your wire management is easier with a penetrating rack and railed system because you're attaching and using the rail to help with the wiring. So for a ballasted racking system, of course, we want to try to use ballast blocks or as few penetrations as possible there. But we can also design to any PSF dead load that you want. And typically, if you do have a ballasted system that is anchored by penetrations rather than by ballast, will have a lot less penetrations than if you were going to a full penetrating array. Typically 10 degrees or 5 degrees is used to limit wind effects. The 15 degree does need more ballasting. Again, we mentioned that 5 degrees or less is the limit on the roof pitch. Also, there is some height limitations, of course, as the wind kind of keeps going up higher you go. We do also want to be careful about not damaging the roof if we have too much dead load added. However, we mentioned we also can easily maintain the roof if needed, remove the array and reinstall it. And also you have to worry about special wire management techniques and how to attach optimizers or microinverters or rapid shutdown devices to the module frames themselves rather than to the racking. So we also see, we can go with most a ballasted racking system, but add penetrations as needed to bring the dead load, as I mentioned, to whatever is necessary. Had one building recently that had a really low dead load limit, and we went with a fully penetrating system using Aerocompact, and we got the half the penetrations that would have been needed if we went with a fully penetrating system. but still got the array dead load down to about 2.2 PSF, which is incredible. The customer was very happy with having such a low dead load on that roof. It was a historical building that they wanted to put it on there. So if the penetrations are located correctly, we can basically prevent the sliding of the array, and we can reduce the ballasting requirements if needed. There is a trade-off, of course. Less penetrations require more ballasting. Typically, each penetration is worth about 250 pounds of ballast, depending upon what you're anchoring to. But that's general rule of thumb is each penetration does offset quite a lot of ballast. And typically, if we combine penetrations and ballast, it might be the best way to meet all of your wind and seismic load requirements. California, of course, and some other jurisdictions in active seismic areas, they'll almost always require some penetrations in an array. We do have different ways to do those penetrations and not violate any roof warranties. Anchor products, they're U-Anchor, OMG, Power Grip Plus for TPO and membrane roofs is very common. Also, the use of a standoff with a ChemLink E-curb is a very, very good way to meet penetration requirements if needed. Here's some examples here of our Aerocompact ballasted racking. So one thing to note is that ballasted racking is in a landscape format, so that keeps the back end of the module from being really high up in the air and grabbing the wind. Some notations, though, that if you're in high snow areas, being that the modules are grabbed on the edges of the frames, we do want to make sure that we're not risking the modules getting damaged from higher snow loads. There are alpine brackets that we can put which support the panels in the middle of the feet if needed. So, you know, we want to make sure those are designed right, and we'll take care of that for you there. Let's see here. The bottom there, the bottom pictures show the example of our east-west tilt. That's a 10-degree tilt facing east and a 10-degree tilt facing west. Modules are paired back to back. So this here especially has very low ballasting requirements, no wind screens needed. It's the lowest cost option, and sometimes it can get to the highest density as well, since inter-row shading is there's none being left there at all. So they're all wind tunnel tested, UL 21703 approved for grounding and fire code compliant. We have full access to the Aero tool design software. Wet stamp support is available for all 50 states. And if we will provide a final engineering with detailed bill of materials as needed. And these metal legs have pre-attached rubber pads that protect the roof surfaces. There's additional rubber pads that go under the ballast blocks and the ballast trays. Really provide superior protection to the roof. Make sure that the roof is not damaged in any way with the install here. Very fast installation, requiring only a single tool. And there are frame mounts, excuse me. And I didn't update that number on the megawatts of installed projects. That was, that's an old number. We're much higher than that now. Here are some examples of anchors. The left one would be a U-Anchor, I believe. I don't think that's a Power Grip Plus. I think that's an Anchor Products U-Anchor. I'm not exactly sure. I forget which one that actually is. And to the right there, you see a standoff flashing that has a cone around it. I don't have a picture of the ChemLink E-curves, but you can see the two types of anchors that could be used here. You can see the L brackets attached directly to the racking, providing flexibility on where that anchor actually goes. But again, we're seeing much, much fewer anchors if you would do an all-penetrating ballasted system with Aerocompact rather than a fully penetrating system with rails. So here's just some examples of some layouts I did. This is based on a Sacramento area. So for production values, I use PV watts. So in 2019, I did this one here and was able to fit 707 modules, and those modules are 300 watt class. So we were able to get 212 kW in that area. So just in 2 years now, 2021, 2-3 years, with modules moving up to 350 watts, being slightly bigger. These are 60 cell modules, of course. Now we're getting almost 35 kW more in the exact same roof area. So great strides there. 17%, about a 17% increase in power that's produced over the course of the year, moving from 327 megawatt hours with a 15-degree south system up to 382 megawatt hours. But again, we mentioned that 15 degrees may not be what you want. So now let's compare the 15-degree south Aerocompact racking with a 5-degree south tilt Aerocompact racking. And PV watts, you're going to take a slight hit in the production of each individual module, but being that we're fitting now 897 modules in this area as opposed to 707, our array size further grows from 247 kW, getting almost 50, 60 kW more in the same area, the same footprint, leaving the same walkways to each of the air conditioning units, the same walkways down the middle of the panel modules, and down the roofs, meeting all your codes. And look at the increase in the megawatt hours we can offer to our customers. So with the 15-degree south racking designed in 2021, 382 megawatt hours, and now we're up to 445 megawatt hours, again, using PV watts, year one production, Sacramento area, but you can definitely see that there. Let's move on. So here's some other comparisons between these two here. We mentioned the 15-degree racking was 700 modules, about 250 kW. Noting here that array was about 3 PSF on the dead load and required 1,500 ballast blocks. If we were to switch to the south tilt ballast racking at 5 degrees, you have a little bit higher roof load because it's a little bit denser module packing. We do need a lot more ballast blocks there, but the dead load is spread out along the roof, and we can do some mitigation there. I also mentioned that the 10-degree Aerocompact was very good on dead load. Since there's no place for the wind to get under the modules, we avoid the use entirely of needed wind screens. So here I was able to place 872 modules. Note that it's a little bit less than the 5-degree, but the dead load went way down to being only 2.61 PSF. And this racking solution only needed 457 15-pound ballast blocks. The cost per watt could be up to half of that of the 15-degree racking. It uses much less materials, no wind screens, much fewer ballast trays. Sometimes we can eliminate the ballast trays altogether since the ballast blocks are well spread out and can be placed directly on the feet of the modules, the feet of the racking. So this is definitely something to consider, is the 10-degree in some larger cases there. This is just an example of the detail on the ballasting plan. So each of those little blocks there that you see, the smaller rectangles are places that don't require any ballast trays, and they have a number in them telling you how many blocks need to be put. Different colors correspond to the number of blocks in each location. The green, longer rectangles are places where small ballast trays are employed, and the gray rectangles are longer ballast trays. So you can see, I'm not certain you can make out the numbers, but there's like 8 or 9 blocks in some of the larger ballast trays. Towards the end there, one of those trays has 16 since it's at the back of the row and doesn't shade any of the modules in front of it. But the detail here is very nice as far as where each penetration in each ballast block goes on a given array. Mentioned SnapNrack here, Ultra Rail. I'm going to fly through this. Most people should be fairly familiar with SnapNrack, but good for pitched roof systems attached to composition roofs, metal roofs, especially with their seam clamps and their metal roof bases. And we can mitigate for high wind and snow conditions if needed with the UR60 rail. And the rail channel lets you do nice wire management, and also our MLP attachment that's shown there allows you to attach a microinverter or an optimizer, and included wire management comes really nice there. What is new for SnapNrack is their speed seal composition foot. So this here is a single device, goes directly to a composition roof. You're putting a sealant in that channel underneath the top picture, and that sealant plus the rubber ring allows for full sealant of the roof on a composition roof. So it's a lag screw that goes directly down into there, hits your structure, and that mount, the completed mount on the bottom, you can see how that works with the UR40 or the UR60 rail. So SnapNrack worked really hard on getting this approved and tested and fully warrantied, and it's proving very popular. Ground mount arrays, doing a lot of Aerocompact ballasted ground mount arrays too, especially Arizona, New Mexico, Texas, Midwest, places that you have light to no snow conditions. I've done a lot of Series 200 ground mount arrays, and those are typically multi-day installs, needing to first lay it out, dig all the piers, the poles, cut all the pipes, set the pipes and the poles in the place, wait for the cement truck, wait for the cement to dry, then assemble the array. Here with the Aerocompact ground mount, you're putting out usually some sort of a landscaping felt on a somewhat flat terrain, and then building your array. And typically you can get a 3-day build down to a 1-day build, just needing the trenching from the array to the point of connection. Up to 1 megawatt of racking can ship to a job site on a single truck roll. No windscreens here. There are some ballast trays that might be needed. And we also can go with a fully penetrating racking with a ground screws. If we don't want to see that for, we've used this for both residential and commercial installations. There's a 15, a 20, the 25-degree tilt isn't very common in the United States, and we also have an east-west configuration. Here's some pictures of some arrays. The top pictures would be the south 15 or 10-degree tilt, or 15 or 20-degree tilt, and the bottom right would be an east-west mount. Now, with that being said, we do still see quite a few installations using our Series 200 ground mount. So this is a 4-high landscape system, and very economical, up to about 150 kW before you start considering something like a pile-driven system, which we'll talk about in just a minute. So in most environmental conditions, we can do 3-foot deep front piers with a brace system, 4-foot deep piers in the back, and that's sufficient to do that. 4 racks could easily do 100 to 120 kW array field, and that would fit into 100 by 150 foot space. About 15 cents to 17 cents a watt. Plus, you need to consider the cost of your support pipe and concrete. So typically, we do see people asking about pile-driven systems, but usually you have to do specialized studies and soil samples to make sure that the piers will stay in place. And then a lot of times for projects with short lead times, the Series 200 system might be much quicker to get permitted and deployed. So here's some examples of our Series 200, just some nice pictures. And move through this one here. Remember that you are locally sourcing your Schedule 40 pipe. That definitely helps on the cost of the racking, that you're getting that larger the pipe locally and not having to ship that. So conversely, for very large projects, we do have the PLP Power Peak commercial ground racking system. This is either a pile driven, or you could mount the cement, mount the piers in cement. This is a 2-high portrait system, so we consider these as tables. We want to know what size of tables and the deployment there. It is a fixed tilt. I believe 20 degrees. I forget exactly what the tilt is, but it is a fixed tilt system, so we can't alter the tilt. We typically do have the pile-driven post systems, and generally the break-even point is about 250 kW and larger. We start to see it worth doing the soil samples, the longer lead times and permitting to go with a pile-driven system. We do have a couple installers that they sell these for residential mounts, where they just like the look of this and they sell this, but they mount, you know, these 14 to 20 panels mounted in concrete piers. And they just set them in concrete rather than doing the pile-driven nature there. It is a nice looking residential ground mount. So when you do locate your inverters for commercial arrays, there's two trains of thought here. One is to put the inverters on the ground mount racking. So on the Series 200, you can put the inverters right behind the panels. All of these inverters are NEMA 4 or 3R enclosures. They allow outdoor mounting, and you're basically locating these decentralized inverters at the panels, and it simplifies your DC array wiring. But you also could put this in a centralized inverter bank and run the wiring back to that bank. We do want to concern ourselves with voltage drop a little bit. Almost all three-phase 480 volt inverters now allow for 100,000 volt voltage max wiring. The new Peak 3s are 1500 volts. You might have to put some fencing or mitigation there to make sure that your jurisdiction is okay with that. So if we do locate our inverters close to the point of connection in an inverter bank, we can get very small wiring, much lower wiring costs from the array to the inverter bank, and it also makes for easier servicing and monitoring if you do that with all the inverters in a single bank. So it looks like I did get through what I needed to get through. I'm open for questions at this point. Erin?
Hey, Glenn. So great presentation. It doesn't appear, at least right now, that we have any questions. So I'll give it a minute. If anybody has any now, feel free to type it in the questions box. If not, always feel free. And I was over here taking notes myself. So, you know, I think that was a lot of great information to take in. So if anybody has questions after the fact, always feel free to shoot us an email, and we'll make sure to get those questions answered. And then, as I mentioned in the intro, there will be, oh, we have a question. Are you seeing many ballasted ground mounts being installed in California?
Yes, quite a few.
Okay. Okay, maybe if anybody else has any.
So there is an intake form. Just send an email to tech@aeesolar.com or to your TSM TSA team, and they can get you in touch with me, and I can give you some preliminary designs and let you know what we can do.
Absolutely. So with that, we'll let everybody kind of get back to their Friday. Hope everyone has a wonderful weekend. And once I close the presentation, or excuse me, the webinar out, that quick survey will pop up. So if you fill that out, we'll send you over the YouTube link for this, as well as the presentation. And you can expect that on Monday once everything's been processed. So thank you to everyone that joined today. Thank you to Glenn. That was fantastic. And without, I think that's it. We've got all the questions answered. We'll go ahead and close out and let everybody have a great weekend.
Awesome. Thank you, Erin.
Right. Thank you, Glenn. Bye-bye.